Alright, this video is for my PreCal students, the Unit 9 test review over polynomials. So in problems 1 through 4 it says determine if the function is a polynomial. If not, give a reason. Okay, so problem 1, yes, it is a polynomial. It doesn't break any of the rules, and it's a good idea to identify the degree. The degree would be 3 here. It's a degree 3 polynomial. You have a degree 2 times a degree 1 factor, so you add those exponents, 2 plus 1, 3, so degree 3. If you multiplied this out, you would end with a cubic term as your biggest term. Biggest exponent would be 3. Problem 2, we have 1 over the quantity x plus 3. We are dividing by x here. X is in the denominator. It's actually a rational function, so no. And you could just tell me that it's rational expression, rational function, or you could just say dividing by x. A polynomial, we cannot be dividing by x. Problem 3 has a negative exponent, so it's not. So no, not a polynomial, and it's because it has a negative exponent. That would be the reason there. Can't have any negative exponents with polynomials. And problem 4 is also a no, because we have a fractional exponent. The square root, taking the square root, is the same thing as raising to the 1/2 power, so we could rewrite this function as x squared plus 7, that quantity all raised to the 1/2 power, subtract 2. So fractional exponent or a square root of any kind, cubed root of any kind, causes it not to be a polynomial. Alright, problem 5 on your review says using roots and end behavior, sketch f of x equals 2x times the x minus 3 quantity squared. So we have a degree 3 polynomial, first degree times the second degree, degree 3, so degree 3. It is positive because the leading term here is positive, so that means that gives us the end behavior, so we'll abbreviate end behavior, is going to be just like the cubic function, so up, right, down, left, positive, up, right, down, left. This is an odd degree, so they go opposite directions. Odd starts with O, opposite starts with O. That's another way that we discussed you could remember it. Now for the roots, we take each factor, so 2x and x minus 3, set them equal to 0 and solve for x, so divide by 2 here. X equals 0 is a factor, is a solution, so that's a root, and it is a single root because it is raised to the first power. This one, x minus 3, solve for x, add 3, so we get x equals positive 3, and that one is a double root because it was raised to the second power. It had a multiplicity of 2. So now we can make our sketch. So make a coordinate plane here. Put in our roots. So we have a single at 0, and we have a double at positive 3. And we put our end behavior in, down, left, and up, right, and now connect going through our root. So a single root we slice through, double roots we bounce, so when I curve down we'll bounce off the x-axis there. So that would be the answer to problem 5. Alright, now for problem 6 on your review. We have, it says use roots and end behavior to sketch x plus 1 times quantity x minus 6 cubed. So we have degree 4. So it's degree 4. It is positive. There's no negative there, so it's positive. Degree 4, positive. So that gives us our end behavior. This is an even degree, therefore the end behavior positive would be up and up. If it were negative, down and down. Even degrees go the same direction for their end behavior. Then we take our factors and find the roots from those. So we have x plus 1, set it equal to 0. Subtract 1, subtract 1. So we get x equals negative 1. That is a single root because it is raised to the first power up here. Then we take our other factor, x minus 6, set it equal to 0 and solve. So we get x equals 6. That one is a triple root because it is raised to the third power. So now we have everything we need to sketch this function. So put our coordinate plane in here, put our roots in. So we have a single at negative 1, single at -1, and a triple out here at +6. So our end behavior, put that in, it would be up left, up right. Now connect going through our roots. So we have a single root at 1, so we will slice through there at -1. And then when we get to 6, we'll have a change in concavity. We have that triple root. So exaggerating this a little bit, it looks like that right on the x-axis. You have the change in concavity there for a triple root. So that would be everything we need for problem 6. All right, now for question 7 on your review, write the polynomial function that contains the point -4, 1, has a triple root at 3 and a single root at -2, then sketch the graph. All right, so if we have a triple root at 3, that's going to give us a factor. We always put the stretch factor a in the front, and then if we have a triple root at 3, that would be a factor of x minus 3 quantity cubed because it's a triple root. And if the root is at 3, the factor has an opposite sign, so it would be a -3 in there. Has a single root at -2, so that would be a factor of x plus 2. Okay, so far that's our function. Now we plug in this point. So -4 goes in for x here, and then 1 goes in for our y. So we have 1 equals a times -4 minus 3 quantity cubed times the quantity -4 plus 2. So work that out. We get 1 equals a. -4 minus 3 would give us -7 all cubed times the quantity -4 plus 2 would be -2. So if we work that out, we're going to get 686 if we put that in our calculator times a here equals 1. Divide by 686 here, and a would be equal to 1 over 686. So now we take that a value and write our final function. So it would be f of x equals our a value, 1 over 686, and then rewrite this part right here. So I'm going to go ahead and write the x plus 2 factor first, and then x minus 3 quantity cubed. So that would be our answer. Now they asked us to sketch it, so we'll put in our coordinate plane here and put in our roots. So we have a triple root at +3 over here, and we have a single root at -2 over here. And because we are degree 4 here and our a value is positive, our end behavior would be up and up. We have degree 3 times degree 1 here, so we add those exponents, degree 4. The single root at -2 we would slice through, and then we have a triple root at 3, so we'll have our change in concavity there, connect up with our end behavior, and that would be the sketch.